All right, so in this video, we're going to talk about energies being stored within capacitors. As you may be well aware of, resistors, they dissipate energy, while capacitors and inductors, which we'll see in a little bit, they actually store energy. So how do we figure out or calculate how much energy is being stored within the capacitor? We want to begin with just an understanding of power. So power being delivered to the capacitor is our trusty equation. Power is equal to your current times your voltage. Now, another variation that you can actually look at if you go ahead and just change the units out, power is equal to your energy divided by T. So in this case, we'll be using the letter U for energy. Some places will use capital E instead. So then what you can do is you can go ahead and isolate U to one side. So you have energy on one side of the equation. Now, when we look at our circuit here, we actually have the same alternating current that's being sent into the circuit here, into the capacitor. So one thing that we know just because we're receiving some sort of alternating current source is that there's usually some sort of change in any given moment because of that sinusoidal wave that's coming in. So if we want to figure out what a snapshot or like at a given time what the power is, we go ahead and differentiate both sides. Du is equal to power times dt. Now, if we want to figure out what the total amount of power across some sort of alternating signal, we're going to go ahead and integrate this. So your energy is equal to, well, there should be an integral sign on this side, but just to kind of speed up here, you just take the integral of your power dt, pdt over here. And from here, we can go ahead and actually recall some of our equations from past. So this equation, it was from a different video. So your current is equal to your capacitance times dB dt. So if we know that power is equal to IV, which is what we got from here, you can go ahead and plug this value into that current, the current that's in the power equation, and you end up with this term here, C times dV dt times V. And then go ahead and swing the dt over to this side, and then you'll end up with this final equation here. Power times dt is equal to C times V times dV. So we can go ahead and take this final result and actually plug it into pdt right here. So then what you end up integrating is, instead of pdt, you integrate the substitute terms here. U is equal to, or your energy is equal to, the integral of C times V times dV. So we can go ahead and move out whatever terms that aren't part of this integral. So C goes out here. And then when we integrate this term right here, this is what you end up with is V squared over 2 from 0 to some sort of final voltage here. So when we go ahead and actually simplify this, because if you have 0 here, then you can essentially cancel out the second term. We end up with this equation here. So we can go ahead and calculate the energy stored in the capacitor by using this equation. U is equal to 1/2 times your capacitance times voltage squared.